So in this video, I'm doing a problem from the Chapter 8 review section, number 6b. So we have this third order equation, and the problem told to use the substitution y equals x to the r. So this is a Cauchy-Euler equation. And we saw this back in Chapter 4, and it's in here because this is related to the method of Frobenius. So that's why it's in Chapter 8. And if, like, we could use the method of Frobenius on here, because if we divide by this x cubed, then we see that all of these things, like the coefficients we get here are like 3 over x and negative 2 over x squared and negative 2 over x cubed. So we see that x equals 0 is a singular point. But this has a special form because this is x cubed, x squared, x, and nothing. This is exactly the form of a Cauchy-Euler equation, and so we don't have to use the full method of Frobenius. We can just use the substitution y equals x to the r and see what happens. If these were other analytic functions, then we might need to have n equals 0 to infinity a n x to the n. And so now I will point out that you could use the method of Frobenius. And what would happen if you did this, and if you went through and plugged everything in, you'd probably get this whole thing equal to a constant or something like that. But anyway, because this is a Cauchy-Euler equation, and because the problem told us to do this substitution, that's just what we'll do now. So if we plug in, we get x cubed times, let's see, r minus 1, r minus 2, x to the r minus 3, right? Plus 3 x squared, r minus 1, x to the r minus 2, minus 2x x to the r minus 1 minus 2x to the r equals 0. And we can simplify this. All of these terms, the reason that this is Cauchy-Euler is that all of these terms match up to being x to the r. So we can pull the x to the r out, and what we're left with is r times r minus 1 times r minus 2 plus 3r r minus 1 minus 2r minus 2 equals 0. We can simplify that polynomial, and when I did that, I got x to the r times r cubed minus 3r squared minus 2, which I can factor. So we have x to the r, r plus 1 squared times r minus 2 equals 0. So this is never 0. So the solution to this has to be equal, either r equals -1 or r equals 2. So what we need, because this is a third order equation, we need 3 linearly independent solutions. We have y1 equals x squared, y2 equals x to the -1. And then if you go back, like we have this double root here, and if you go back to the section on Cauchy-Euler equation, we found that another linearly independent solution looks like x to the -1 times ln of x. So we can see what section is it? C section 4.7 for why that was the case. So that means the general solution looks like y equals c1 x squared plus c2 x to the -1 plus c3 x to the -1 ln of x. And that is our answer.